Suresh here, Games Academy faculty for Biochemistry. So as part of our Fmge test series June session 2023, so here I come up with another case-based question. So let's jump into the case. So a 1-year-old female child with progressive abdominal distension, vomiting, and lethargy for 2 months. So by inquiring the past family history, there was no history of seizures or recurrent infections. Slightly delayed development has been observed. Death of a cousin during infancy due to liver disease. And on physical examination, the baby had round doll's face, fatty cheeks, a protuberant abdomen, massive and firm hepatomegaly. Kidneys were palpable, spleen not palpable. So on laboratory investigations, low blood glucose levels has been noted, high lactic acid level, that means hypoglycemia, lactic acidemia, hyperlipidemia and hyperuricemia. So these are all the conditions has been noted with the values like low blood glucose levels, high lactic acid levels, high lipid levels, maybe PAG or cholesterol, hyperuricemia, higher uric acid levels. So when you go with the other parameters, there is mild elevation in liver enzymes also. ABG analysis, arterial blood gas analysis shows high anion gap with metabolic acidosis. Urine, actually to say Benedict's test is negative, that means absence of sugars in the urine. So when you go with liver biopsy, hepatocytes contain greater than normal amounts of glycogen. So here with the liver biopsy, you can make out that there is accumulation of glycogen in the hepatocytes. Right. So with this, what you can make out? So this explains this case itself with all the investigations, physical as well as laboratory and biopsical study, explain that this case is related to glycogen storage disorder. So we have already learned about glycogen storage disorder on our theoretical videos, which have already been uploaded in our app. So if you recall, so there are certain types of depending on the textbook, like some textbook they mentioned 7, some textbook they mentioned 9 glycogen storage disorders. Out of these 7 are very important. So based on these features here, hypoglycemia is a prominent feature and lactic acidemia is noted, hyperlipidemia is also there and hyperuricemia. So these are all the characteristic feature of this, and physical examinations protruded abdomen. So I can clearly say this case is strictly related to type 1 glycogen storage disorder, that is von Wieck's disease. So what are the key points? Here key points we can say: round doll face, fatty cheeks because hyperlipidemia, so accumulation of fats in the outer extremities, right, and protruded abdomen as glycogen is accumulated in the liver cells, so there is a bulging of the liver, so leads to hepatomegaly, right. Kidneys were palpable because of the hepatomegaly condition. So it is a clear-cut case of von Wieck's disease. And what for von Wieck's disease? What are the characteristic symptoms? If you recall, von Wieck's disease due to deficiency of enzyme glucose 6-phosphatase. And again, there is 1A and 1B. So 1A is mainly because of the deficiency of the enzyme glucose 6-phosphatase. There is a defect or mutation in the gene which codes for glucose 6-phosphatase. So there is complete absence of this enzyme. So there is no breakage of glycogen to free glucose. So abnormal glycogen normal glycogen content cannot be broken down to glucose, so they will be accumulated inside the hepatocytes because glucose 6-phosphatase is exclusively present in liver cells. Remember all this. Understand? And next point is there is a 1B is also there, that is deficiency of translocator of glucose 6-phosphatase to endoplasmic reticulum. So as this translocator is, because remember here, glucose 6-phosphatase is present in the endoplasmic reticulum of hepatocytes. So for that, this glucose 6-phosphate is supposed to be transported to endoplasmic reticulum through a transporter, right? So that transporter is absent in case of, though there is a active form of glucose 6-phosphatase, this glucose 6-phosphate cannot be transported to inside the endoplasmic reticulum. So that is the reason this enzyme is not transported to endoplasmic reticulum, and there is a no breaking of glycogen. Yeah. So we have already discussed what is the most likely diagnosis, and we have given justification. Mention the cause: deficiency of glucose 6-phosphatase. Uh, Mention the biochemical basis for hepatomegaly, fasting hypoglycemia, hyperlactemia, metabolic acidosis, hyperuricemia, hyperlipidemia. Yes, I'll just discuss. So here you see, as I said, xanthoma, apple cheeks, and round doll face, thin extremities also you can observe in physical examination of von Wricht's disease. And hepatomegaly, you can see hepatorenal like protruded abdomen. This is also characteristic feature if they show you in an image. And characteristic feature, if you see, there is a hypoglycemia. As glucose 6-phosphate is not there, glucose 6-phosphate cannot be transported inside the inside the endoplasmic reticulum, because glucose 6-phosphate is present in the endoplasmic reticulum. So glucose 6-phosphate accumulates in the liver. So as there is no free glucose, what happens if there is no free glucose? Leads to low levels of glucose, hypoglycemia. So one Wricht's disease prominent feature is low blood glucose levels, hypoglycemia. So that is one biochemical basis. Then whatever the glucose 6-phosphate accumulated inside the cytoplasm will diverted for other alternative mechanisms, such as glycolysis to form end product like pyruvate, and pyruvate can be, not all the pyruvate will be converted to acetyl-CoA. So some of them will be diverted for lactate, leads to lactic acidosis, and not all the acetyl-CoA produced through this will not enter into TCA cycle. So they will convert into ketone bodies. So increase in the production of ketone bodies. So that's why ketoacidosis you can make out. And whatever the acetyl-CoA entered, it will be converted to citrate, and there is a high levels of pyruvate and high levels of energy. So this citrate cycle will not take place, and this citrate will be diverted for fatty acid synthesis, that such as triglyceride formation and cholesterol formation, to make hyperlipidemia. This is one condition. And again, this glucose 6-phosphate enters into HMP shunt to produce NADP. Yes, the function of HMP shunt is to produce pentoses for nucleic acid formation, and NADP for fatty acid synthesis, steroid synthesis, and for respiratory burst and maintaining the RBC membrane. So this NADPH again favors the fatty acid synthesis, leads to hyperlipidemia. And another thing, so as lactate is competing, like what to say, there is increased levels of lactate leads to hyperuricemia. That's another prominent feature. So HMB shunt increases means more amount of PRPP available, more amount of PRPP means more amount of purine biosynthesis, more amount of purine biosynthesis, more amount of purine degradation results in uric acid production. So high levels of uric acid in circulation leads to hyperuricemia, which start excreting in the urine as well. So these are all the biochemical basis for the characteristic features of von Wricht's disease. So, these are all the biochemical basis. So treatment part, if you see, so how to manage von Wricht's disease? Gene therapy is one of the method is still on trial. For managing hyperuricemia, allopurinol, which is competitively modifying drug, which competes with xanthine oxidase to decrease the production of uric acid. And hyperlipidemia will be minimized by giving oral drugs like fenofibrate, orlistat, and estimate. And hypoglycemia managed by giving uncooked cornstarch, frequent infusion of glucose. That is, short meals may improve the situation. Antihypertensive drugs also can manage the situation. So that's all about today's question, case-based discussion. Hope the session is fruitful, and I'll be coming up with the next case-based question. Thanks for watching. Thank you.